All right, welcome back, everyone. Before we begin the lecture, this is the spreadsheet that I'm going to upload so you can have it. And it shows you the hexadecimal table. You see it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, 10, B, 11, C, 12, D, 13, E, 14, and F, 15. It's really 16, right? Because it starts at 0. So that's why they call it a base 16, okay? So there's your hex table right there. There are your binary bit values. I made a little example of an IPv6 address right here. And obviously, you know what a MAC address looks like. But I will be uploading this and make some other stuff to help you out. But remember, you have the video. You can always pause, see the concepts, and then continue on, okay? But let's go to the next step, which is converting a decimal to a hex number. Now, I picked easy numbers because I want you to understand the concept. I ain't got to show you physics so you can learn how to do this. This is to learn a concept. All right? Remember, since we had decimals, we had to break it down into its binary format, right? Binary is the middle ground. Well, same thing goes here. All right, so we got 192. So the first thing that we need to do is find out where's 192. So let's put in our bit values, right, for so we can get the decimal. 128, 64, 32, 16, 8, 4, 2, and 1. All right, those are 8 bits, which creates a byte, which means you got a number or letter or what have you. So 128 and 64, that gives you 192 if you add them together. The rest are zeros. They're all off. And I'll finish that 0 underneath the 16 because it looks like a C. There you go. All right, that is 192 in its binary format. So we'll work from right here. I'm going to change the color. Let's make it blue. Now we need to remember, hexadecimal numbers are what? 4 bits long. So 1, 2, 3, 4. We draw a line. What is the bit value now? What is the bit value for each hex number? So 1, 2, 4, 8, 1, 2, 4, 8. The only reason I left these bit values up top is because we're going to use them again. I didn't want to write them again. But 1, 2, 4, 8, 1, 2, 4, 8, those are the bit values for hex numbers. So what's on? Well, on this side, the 8 and the 4, that's 12. What's on this side? Nothing. Well, that's 0. Well, A is 10, B is 11, C is 12. So C, 0. So 192 is the equivalent to C, 0. C, 0. Take the pencil on there. C, 0. And all I did was change that number to its binary format, break it up into 2 sections of 4. At the bottom, I put in the bit values and then just added what was on, which in this case came out to 12. And I found out through the hex table that 12 is C, 0 is 0. Therefore, 192 is 0. All right, let's do it again. Let's do 240. But again, I'm doing easy numbers just so you can understand the concept. The concept. That's what you need to understand. Well, I erased everything anyway, so I got to rewrite it again. All right, and it was in black, yes. So we're going to do 240 now. So 128, 64, 32, 16, 8, 4, 2, and 1. So 240. What is 240? 1, 2, 3, 4. If you add those 4 numbers, that'll equal to 240. The rest, 1, 2, 3, 4. Okay? So again, you have to break it up into sections of 4. Get the blue, 1, 2, 3, 4. Line, 1, 2, 3, 4. So on the bottom, let's put those hexadecimal bit values, which is 1, 2, 4, and 8. 1, 2, 4, and 8. They're all on. That means 15, correct? 8 and 4, 8 and 2 is 10, 4 is 14, and 1 is 15. This is 15, which equals F. And this, nothing's on, so that's 0. Therefore, F 0. So 240 in hex is F 0. That's a funky looking F, but that's okay. All right, there it is. Again, same concept, same concept. Last example. Let me see if I can not erase the top numbers, which I probably am. Yes, I am. Getting better though, I got 2 numbers now. All right, get black, 64, 32, 16, 8, 4, 2, and 1. What number we have now? 248. 1, 2, 3, 4, 5. 1, 2, 3. That's the binary format for 248. We get it blue. Again, 4, 1, 2, 3, 4. Line. We do the bit values for the hex at the bottom, just because I don't want to erase the top just yet. 1, 2, 4, 8. 1, 2, 4, 8. They're all on. That's 15, which equals F. Now here we have 1 on, 8. So this is 8. So F8. So 248 in decimal, or in hex I should say, is F8. And that is it. Now, I know you're wondering, wow, this guy must be a great mathematician. He's just adding those numbers up like left and right and under 5 seconds, nothing. No. I know because there's another table that you memorize. And after you work with this, it's just like your times table. You know it automatically. I know that 1 bit is 128, 2 bits is 192, 3 bits is 224, 4 bits is 240, 5 bits is 248, 6 bits is 252, 7 bits is 254, and 8 bits is 255. These are things in networking when you're doing especially subnetting that you need to know off the top of your head. But again, I have a course on that in IP version 4 on the site. All right, so there's your converting from decimal to hex. Again, binary was the middle ground. We turned the decimal to binary and then to hex. Again, under 30 seconds, and I'm explaining. Very simple. If it isn't under 30 seconds, somebody's timing me, I guarantee it's under a minute. But if you're just doing it to do it, you're going to do it in 30 seconds. All right, I'll see you in the next lecture.